the 6 trigonometric ratios. We have the learning target for this video. We have I can solve for the measure of the remaining sides and angles when side and acute angle of a right triangle are given. Let us have a short recall on the prerequisite topic for this video. We have our formulas for the 6 trigonometric ratios, starting from sin theta equals opposite divided by hypotenuse, cosine theta equals adjacent divided by hypotenuse, tangent theta equals opposite divided by adjacent, cosecant theta equals hypotenuse divided by opposite, secant theta equals hypotenuse divided by adjacent, and lastly we have cotangent theta equals adjacent divided by opposite. And aside from this, we had our activity about special triangles and getting the trigonometric ratios through the help of our special triangles, and we were able to get these details. I hope you are familiar with the 6 trigonometric ratios, and we have here the 30-degree angle, 45-degree angle, and 60-degree angle. Now, let's have additional practice exercises in getting the 6 trigonometric ratios. Let's have number 1. Determine the 6 trigonometric ratios of P. But of course, take note, you need to simplify the ratios if necessary. In our first illustration, I told you last time, before you proceed with getting the 6 trigonometric ratios, you need to check first the illustration and check the details on measurement or measure of each side of the given triangle. And I told you it must be complete. So as you can see, we have here one of the sides measures 20 and the other side measures 12. And then lastly, we have third side measures 16. So we can say that the details on the measures of the sides of the given triangles are all given. So that means we can proceed with getting the 6 trigonometric ratios. But of course, before we start with using the formula for the 6 trigonometric ratios, I told you that you need to identify the measure of the opposite side, hypotenuse side, and adjacent side. So first, for opposite side, it measures 12. Next, for hypotenuse side, it measures 20. And lastly, for adjacent side, it measures 16. Now, we were able to sort out necessary data for our 6 trigonometric ratios formulas. Now, let's start with sine. So, sine P equals opposite divided by hypotenuse. Substituting in the formula, we'll have 12 over 20 or 3 over 5. I told you that if the ratios can still be simplified, then you need to simplify. Next, we have cosine P. We all know that the formula for cosine is adjacent divided by hypotenuse. Then substituting the details in our formula, we'll have 16 over 20. Of course, we can see that it can still be simplified. So, we'll have 4 over 5. Next, for tangent P, our formula is opposite divided by adjacent. Substituting in the formula, we'll have 12 over 16. We can see that this expression can still be simplified. So we will have 3/4. Next, we still need to get 3 remaining trigonometric ratios. So we have here, for cosecant P, hypotenuse divided by opposite will have 20 over 12. We can still simplify this. We'll have 5 over 3. Next, we have secant P. Hypotenuse divided by adjacent will have 20 over 16. We can still simplify this. We'll have 5 over 4. And lastly, for cotangent P, adjacent divided by opposite will have 16 over 12. We can still simplify this, so we'll have 4/3. Okay. So next activity, use the figure below. So this is our problem. Given A equals 10 and C equals 26, find B and the 6 trigonometric ratios of A. So again, side A is equal to 10, side C equals 26, and you need to find the 6 trigonometric ratios. So here, because the other side, the measure of the other side is not yet given, so we need to look for the measure of the other side by using the Pythagorean theorem. But of course, we need to determine first the necessary data. For opposite side, wherein we're going to refer as A, it is equal to 10. For hypotenuse side, which refers to C, it is 26. And of course, for adjacent side, we don't know yet. And that is our first task. So here, given A equals 10 and C equals 26, find B. So, we use Pythagorean theorem. C squared equals A squared plus B squared. Now, substituting in the given formula, we have 26 squared equals 10 squared plus B squared. So 26 squared is 676. 10 squared equals 100. So combining like terms, we'll have 676 minus 100 equals B squared. Continuing the process, we'll have 576 equals B squared. This is not yet the final answer. Of course, we need to get the square root of both sides of the equation. So we have here square root of 576 equals square root of B squared. We'll get 24 equals B. That means our adjacent side measures 24. Now, since we were able to get all the necessary data for each sides of the given triangle, we can now proceed with getting the 6 trigonometric ratios. Let's start with sine A. We all know that the formula for sine A or sine theta is opposite divided by hypotenuse. So, substituting in the formula, we'll get 10 over 26. We can still simplify this. So, we'll have 5 over 13. Next, for cosine A, we have adjacent divided by hypotenuse. Substituting the details in the formula, we'll have 24 over 26 or 12 over 13. Next, we have tangent A equals opposite divided by adjacent. We'll have 10 over 24. And we can still simplify this. So we have 5 over 12. Next, remaining trigonometric ratios, we have cosecant, secant, and cotangent. So let's have cosecant first. So So the formula for cosecant, we have hypotenuse divided by opposite. The same way, substituting in the formula, you'll have 26 over 10 or 13 over 5. Next, we have secant A equals hypotenuse divided by adjacent. We'll have 26 over 24 or 13 over 12. And lastly, for cotangent A, we have adjacent divided by opposite side. We'll have 24 over 10 or 12 over 5. Now, let's proceed with the last activity. Use the figure below again, and the problem is, given that A equals 18 and B equals 18, find C and the 6 trigonometric ratios of A. As you can see, in our problem, A is given, B is given, but C is not yet given. Identifying the measures of each side, we have for opposite or refers to A, we have 18. And for B, so hypotenuse equals C, or it's the missing detail. And for B, we have the adjacent side, which is 18. Now, our task is to find out the measure of C, or the hypotenuse side. Now, let's start with this. Of course, to find out the measure of the other side, we are supposed to use the Pythagorean theorem. The formula C squared equals A squared plus B squared. We are supposed to substitute the given data to our formula. So we'll have C squared equals 18 squared plus 80 squared. So 18 squared is 324 and 80 squared is 6,400. And combining 324 and 6,400, we'll have 6,724. It is not yet the final answer. We need to get the square root of the both sides of our equation. So we have here square root of C squared and square root of 6,724. Then C equals 82. So that means the measure of our hypotenuse, or the C side, is 82. Now, since we were able to complete already the details for the measure of each side of the given triangle, we can now proceed with finding the 6 trigonometric ratios of A. For sine, we are particular with the formula already. Opposite divided by hypotenuse. Substituting in the formula, we'll have 18 over 82. And of course, if it is necessary to be simplified, then we need to simplify. So, it is equal to 9 over 41. For cosine A, we have 80 over 82, or 40 over 41. Okay, next. For tangent A, we have opposite divided by adjacent. So, we'll have 18 over 80, or 9 over 40. So we're able to get already the 3 trigonometric ratios. And of course, for us to be able to get the remaining 3 trigonometric ratios, which are considered the reciprocals of this first 3, so we just reciprocate our answer for sine, cosine, and tangent. So let's start with cosecant A. We'll have 82 over 18, or 41 over 9. For secant A, we have 82 over 80, or 41 over 40. And lastly, for cotangent A, we have 80 over 18 or 40 over 9. So we're done with the last problem for this video. Okay, thank you so much for watching. I hope you learned out of this video. Please don't forget to subscribe and click the notification bell so that you will be updated of our playback videos. Thank you.